pull up any satellite map of Western Australia. Zoom in slowly, past the red emptiness, past the white salt pans, past the long brown rivers that vanish into the sand before they ever reach the sea. Keep zooming, find the gorges, find the canyons. Karijini, Kalbarri, Winjana, Geki, Hammersley. Look at them from above. Not from the postcards, not from the tourist brochures, from above. From the cold, flat eye of a satellite that does not care about geology textbooks. And tell me honestly what you are looking at, because what you are looking at, if you let yourself look, is not what rivers do. Rivers wander, rivers braid, rivers loop and curl and double back on themselves when the land is flat and they have time. When rivers cut deep, they cut crooked because water follows weakness and weakness is never straight. But the canyons of Western Australia are not crooked. They are not wandering. They are slots. Long parallel slots cut into rock that is 2.5 billion years old. Rock so hard that modern diamond saws struggle with it. Rock that should not be sliced like cheese. And yet there it sits, sliced, walls vertical, floors flat, edges sharp. Cuts that run for kilometers in a single direction with the patience of something that knew exactly where it was going. And here is the part that the textbooks never quite explain. The rivers that supposedly carved these canyons are gone. Some of them never existed. Some flow only after the rare cyclone. A few centimeters of water moving through a chasm 300 meters deep. The math does not work. The water budget does not work. The timeline does not work. And the further north you go into the Kimberley, into the deep red country where the old people have been telling stories for 40,000 years, the more the math falls apart entirely. So tonight we are going to walk through 20 of these canyons, slowly, quietly. The way you would walk through a place you suspect might be older and stranger than you were told. And we are going to ask, with no agenda and no anger, just curiosity, what cut these? Because something did, and it was not a river. Before we go any further, take a moment. Whatever you are listening on, settle in, get comfortable, lower the lights, pull the blanket up. This is a long walk, and I would rather you arrive at the end of it rested than awake. If you find this kind of slow, quiet history useful, the kind that asks questions without shouting, then the subscribe button below is how we keep walking together. The little bell beside it is how you will know when the next one is ready. There is no pressure, there is no rush, just a small tap and then back to where you were. And if you find yourself drifting before the end, that is not failure. That is the point. Sleep well. We will still be here, walking through the red country when you come back. The canyons have been waiting 2 billion years. They can wait one more night. Now, let us begin. Western Australia is, by some measures, the second largest subnational division on Earth. 2.5 million square kilometers. Most of it old, most of it empty, most of it the color of dried blood when the sun is right. And running through that immensity, scattered like the cuts of an enormous, careful, patient knife, are gorges. We are going to look at 20 of them, 20 places where the ground simply ends, drops away into a slot, and reveals walls of banded iron and red sandstone that have no business being so clean, so straight, so deliberate. Some of these you may have heard of. Karijini perhaps, Kalbarri perhaps. The Bungles you have certainly seen in a calendar, even if you did not know what they were called. Others are obscure enough that even most Australians could not place them on a map. But every one of them, when you look at it with fresh eyes, says the same quiet thing. I was not made by water. I was made by something that came through here once, did its work, and left. We will move from south to north, more or less, because that is the way the country itself seems to want to be read. We will start in the Hamersley Range, in the deep heart of the Pilbara, and end in the high stone country of the Kimberley. 20 canyons, 20 cuts. One question. Let us see where it takes us. Number 1. Dale's Gorge. Dale's Gorge is where most people first meet Carragini, even if they do not know that name. It is the postcard. The pool at the bottom, called Circular Pool, with its black water and its dripping walls of ferny moss. The waterfall called Fortescue Falls that steps down in flat shelves like a staircase someone built and then forgot. The narrow path along the floor of the gorge where the red walls rise on either side of you, vertical, layered, banded with the dark iron stripes that geologists call banded iron formations. The official age of this rock is 2.5 billion years, half the age of the Earth. Older than oxygen in the atmosphere, older than complex life. The textbook says these layers settled out of an ancient ocean, microbes breathing iron into the water, slow rust falling like snow onto the seafloor, building up year after year for hundreds of millions of years. That is the textbook, that is the story. But stand at the rim of Dale's Gorge and look down. The walls do not curve, they do not soften, they drop. 200 meters of layered rock, alternating dark and light bands, each band a centimeter or two thick, stacked like the pages of a book someone has set on its end and sliced cleanly down the middle with a saw. The cut is so clean that in places you can see where the same layer continues on the opposite wall. Same color, same thickness, same little quartz inclusion, as if the two walls were once a single block, and then the middle was simply removed. The river at the bottom, the one that supposedly did all this, is called Dale's Creek when it runs, which is rarely. Most of the year it is a chain of still pools, a few of them deep enough to swim in. Most of them are polite ankle deep. The catchment above the gorge is small. The rainfall is light. There are no glaciers. There never were. There is no obvious mechanism, no patient grinding force that explains how this slot got cut 200 meters into rock that resists almost everything. And yet there it is, the cut with its parallel walls and its flat floor and its waterfalls that step down in such regular intervals that you start to wonder, quietly, whether someone counted them. The Banyijima people, whose country this is, have a different story. They speak of beings who traveled through this land in the deep time before time, not making it gently, not eroding it, cutting it, shaping it, leaving signs. The stories are old enough that the names of those beings have outlived empires. And the stories do not say river. The stories say something came through and did this. Stand at circular pool at the bottom in the late afternoon. The light falls down the walls in long, slow sheets, the way light falls through high windows in a cathedral. The water is so still it doubles the walls, so that the cut goes down again into the pool, mirrored. 200 meters of red rock above, and 200 meters of red rock below in the reflection, and you are standing in the middle of a slot that goes both ways. There is no sound, there are no birds, there is just the small drip of water from the moss, every few seconds, the only clock in the place. And the question sitting there with you in the quiet, what cut this? Number 2, Hancock Gorge. If Dale's is the postcard, Hancock is the secret. You reach it by climbing down a ladder bolted to the rock, and then another ladder, and then a third, until you are standing on a narrow ledge, perhaps 80 meters below the rim, with the red walls now leaning in on either side, closer than the width of a small room. From here you walk, there is no path. You walk on the floor of the gorge itself, on rock that has been polished by water and by feet until it shines like wet metal. The walls press closer. The light overhead narrows to a band of blue. The temperature drops. The sound changes. Every footstep, every drip, every breath comes back to you doubled and trebled by the closed walls, and you realize you're walking inside a slot that, if you reached out your arms, you could touch both sides at once. This slot is called Hancock Gorge, and the deepest narrow part of it is called the Spider Walk because you have to spread your arms and legs against both walls and shuffle along that way, with the water rushing beneath you in a channel no wider than your boot. Beyond the Spider Walk is a chamber. The walls open out into a small natural amphitheater with a deep green pool in the floor of it called Kermit's Pool. The water is cold. The walls rise sheer on every side. There is no obvious way out except the way you came. Now, look around in that chamber. Look at the walls. The bands of iron and chert run horizontal, perfectly horizontal, across one wall, around a curve, onto the next wall. The same band continues, the same color, the same thickness. If you were standing inside a layer cake that someone had carefully hollowed out from the middle without disturbing the layers, this is what it would look like. The geometry is too clean. The continuity of the layers across the curves of the walls is too perfect. Water cutting through fractured rock does not do this. Water cutting through fractured rock leaves jagged steps and broken edges, because rock fractures and falls. This rock did not fracture and fall. This rock was removed. The Pilbara Aboriginal stories speak of the rainbow serpent passing through here, not bringing the water, making the channel. The serpent went through the rock, and the channel was its path. That is the story. And when you are standing in Kermit's Pool with the cold green water at your knees and the walls leaning in 80 meters above you, that story makes more sense than the river story does, because there is no river here. There is barely a trickle. There is a hint of water in the floor of the slot that, in any normal landscape, could not have done a fraction of a % of the work that has been done in this place. Geologists will tell you that the gorges of Karijini were cut over 40 million years by water that no longer exists, in climates that no longer exist, by rivers that no longer exist. That may be true. But 40 million years of water that no longer exists is a hypothesis that cannot be tested because the water is not there. What is there is the cut, and the cut is too clean, too straight, too patient, too deep. Sit on the rim of Hancock at sunset. The shadow rises out of the slot like a tide. The red walls go from copper to rust to wine to black. The little band of sky overhead turns lavender. Somewhere far below, the water in Kermit's Pool turns from green to deep ink, and then to nothing visible at all. The slot becomes a mouth in the ground, a long, careful mouth opened by something with very steady hands. Good night, Hancock. Sleep well. We are moving on. Number 3, Wiano Gorge. Wiano is the sister of Hancock, just across the ridge, and the two gorges almost meet at a place called Oxa Lookout, where 4 canyons converge. Stand at Oxa in the late morning. The sun is just high enough to drop straight down into the gorges. You are looking at 4 cuts in the rock, 4 slots meeting at almost the same point, like the spokes of a wheel without the rim. 4. Meeting at a point cut into 2.5 billion-year-old banded iron. Think about that for a moment. 4 rivers, all of them small, all of them seasonal, all of them no more than ankle deep most of the year. Supposedly carved 4 gorges 300 meters deep into rock so hard that the modern iron mines 100 kilometers east of here use industrial explosives to break it apart. And those 4 gorges happen to meet in a star pattern at one point. The probability of that being a coincidence of erosion is so small that no one in the textbook tradition has ever quite explained it. They have just gestured at it. Faulting, they say, jointing in the rock, old fracture patterns. Perhaps. Or perhaps something came down here once and made 4 cuts radiating from a single center, the way you would slice a pie if you were going to lift out a wedge. The walk into Weno takes you down into the slot, past the upper pools where the water is shallow and warm, past the lip of stone where the water tips over into the deeper gorge, down a series of natural shelves that are so regular in spacing that they look like steps. They are not steps in the engineered sense. They are not square. But the spacing between them is suspicious. The rises are about the same height. The treads are about the same depth. If you measured them, which a few amateur researchers have done over the years, you would find a kind of repeating module. The same module that appears in the shelves at Dale's, the same module that appears at Joffre, the same module that appears scaled up in some of the formations of the Bungle Bungles 1,000 kilometers north of here, as if whatever did the cutting had a setting, a preset, a standard depth of cut. At the bottom of Weno is a place called Handrail Pool. There is a single metal rail drilled into the rock by the park service that helps tourists lower themselves down the final wet drop into the pool. The pool itself is round, almost perfectly round. A circle of dark water, perhaps 8 meters across, with walls rising vertical on every side, and a single narrow notch where the gorge continues downstream. It looks like a drain. It looks like the place where the cutting tool was lifted briefly so the operator could check the work. The walls of Handrail Pool are smooth. They have the polish that water makes over thousands of years, yes. But underneath the polish, when the sun comes in at the right angle and lights the rock obliquely, you can see something else. You can see the lines, faint parallel lines running across the rock, all of them in the same direction, all of them at roughly the same spacing. The geologists call these striations. They say they are scratches from sand carried by the water. Sand, carrying enough force to scratch banded iron formation. Banded iron that has to be blasted out of the ground at the Tom Price mine just a few hours' drive from here. Maybe. Or maybe those parallel lines are the marks of the tool that cut this. Tool marks. The way an old stonemason's chisel leaves regular lines along a dressed block. The way a saw leaves regular lines across a cut beam. Lines that should not be there if water alone did the work. Lines that are exactly the kind of thing a careful eye looks for when it suspects the explanation it is being given is not the whole story. The Banijima word for this country translates roughly to deep place. Not deep river, not deep valley, deep place. As if the noun itself acknowledged that what mattered here was the cut, not what flowed through it after. Lie back, close your eyes if they are not already closing. Imagine standing at the bottom of Handrail Pool in the cool dark with the ring of stone above you, and the single notch where the cut continues, and the faint parallel marks on the walls catching what little light comes down. Imagine someone standing there 2 billion years from now. in some far future country, looking at the same marks and wondering the same thing. What cut this? We will find out. Or we will not, but we will keep looking. Good night, Wano. On we go. Number 4. Joffre Gorge. Joffre is the one with the falls, a single high amphitheater of red rock, curved like the inside of a great bowl, with a thin band of water dropping from the rim into a deep pool at the bottom. In the wet season, the water arrives in a wide sheet. In the dry season, it is a delicate ribbon, the kind of waterfall a child would draw with a single soft pencil stroke. Either way, the fall itself is not what makes Joffre interesting. The amphitheater is what makes Joffre interesting. Stand at the lookout above the falls. You're looking into a hollow scooped out of solid rock. The walls curve in a smooth arc around 3 sides. The 4th side is the lip where the water tips over. The arc is not random. The arc has a center. If you trace the curve with your eye, you can find the geometric center of the bowl somewhere in the air above the pool, and from that imaginary point, the walls are very nearly equidistant, as if someone had set the point of a compass there 2 billion years ago, and turned it once, and the rock obeyed. The textbook explanation for a plunge pool amphitheater is straightforward. Water falls, water pounds the rock at the base. The base erodes faster than the top. The top eventually overhangs. The overhang collapses. The pool retreats upstream. Over millions of years, the gorge migrates up the valley, leaving an amphitheater at every old position of the falls. This is the standard explanation, and for many waterfalls on softer rock, it is a reasonable one. But Joffre is cut into the same banded iron formation as the rest of Karijini, the same stone that requires explosives at the iron mines. And the water that supposedly carved this bowl is, in the dry season, the volume of a kitchen tap left running. The volume of water that has run through this amphitheater over the supposed 40 million year carving period, if you do the math, is not nearly enough. Not by orders of magnitude. The energy budget does not close. Something else closed it. Something that does not run dry in October and November. Something that did its work and went away. The other thing about Joffre, and you only notice this if you climb down into the bowl and stand in the pool at the bottom, is the way sound behaves. Speak softly. Your voice comes back, not as an echo in the loose sense, but as a focused return. The curved walls gather sound. They focus it the way a parabolic dish focuses radio waves. Stand at the focal point of the bowl, somewhere in the center of the pool, and a whisper from one wall arrives in your ear as if someone was speaking directly into it. The Banyijima knew this. They used places like Joffre for what we might call counsel, for talking, for listening. The shape of the bowl carried the words. The bowl was the room. That is not the kind of acoustic geometry you get by accident. That is the kind of acoustic geometry you get when something cut the bowl with intent, and the curve was not a happy coincidence of erosion, but a designed result. Or, if you prefer the safer interpretation, it is the kind of acoustic geometry that the people who came after the cutting recognized and used and folded into their ceremony. Either way, the bowl is a room. It was a room before there were rooms. It is a room still. The waterfall at Joffre in the dry season makes a sound like someone slowly tearing silk. The pool at the bottom is the color of weak black tea. The walls are the color of dried blood with veins of charcoal running through them where the iron bands are thickest. The shadow inside the bowl is cool. The air smells faintly of wet stone and ancient pollen, and the particular dryness that very old rock has when it has been sitting in the sun for 500 million years. Lie back. Let the bowl curve around you in your mind. Let the soft sound of the falling water do what it does. There is something about a curved space that the human body remembers from before there were houses. The cave. The amphitheater, the bowl. Joffre is one of the oldest of them. Older than any cathedral, older than any temple, cut by whatever cut it before anything that breathes the way we breathe was here to listen. Good night, Joffre. On number 5, Knox Gorge. Knox is the long one. Where Hancock and Weno are slot canyons, narrow and intimate, Knox is broader, longer, deeper in a different way. You can walk down the floor of Knox for a kilometer before the walls begin to crowd you. The light reaches all the way to the bottom in midday. The pools are larger. The rock terraces step down in long flat shelves like the floors of an old building. And the walls, here more than anywhere else in Carigini, show their structure clearly. You can see the banded iron, the chert, the dolomite, the thin lenses of softer material that the geologists love because they tell the story of the ancient ocean floor. Reading the walls of Knox is, for a geologist, like reading an open book. The story is right there, layer by layer, 2.5 billion years of patient sediment. But the cut is the part the book does not explain. Walk to the place where the floor of Knox drops away into the lower gorge. There is a viewpoint there on a flat shelf of stone that looks down into a section called Knox Slot. The slot is perhaps 3 meters wide. The walls of the slot drop 120 meters to a single thin line of water at the bottom. The slot runs in a straight line almost due north for nearly a kilometer. 120 meters deep, 3 meters wide, straight, for a kilometer. Pause on that. A trench 3 meters wide, 120 meters deep, running straight for a kilometer, cut into rock that, again, modern iron mines a few hundred kilometers away cannot break without high explosives. The aspect ratio of that cut, depth to width, is roughly 40-1. Natural water channels in hard rock in any of the studies done on canyon morphology around the world almost never exceed aspect ratios of 10-1. To get to 40, you need something else. You need a process that goes down faster than it goes sideways. You need a process that cuts on a narrow front and does not widen as it descends. There are only a few things in nature that do this. Glaciers in certain conditions, catastrophic outburst floods in certain rare cases, or processes we have not catalogued because they are not happening now. There are no glaciers in the Pilbara. There have not been glaciers in the Pilbara in any recent geological epoch. Catastrophic outburst floods leave specific signatures, plunge pools at the head, depositional fans at the mouth, scoured shoulders on the surrounding plain, and Knox shows none of these signatures. The slot just exists, straight, narrow, deep, as if cut. As if a wire or a beam or a tool of some kind was lowered into the rock from above and drawn slowly along a planned line, and the rock simply parted along that line, and what fell away cleanly. Whether that tool was wielded by something we would call a person, or by some process of the earth itself that we no longer see in operation because the conditions that produced it are gone, or by something stranger, is the open question. The textbook answers it with water, because water is the only tool the textbook has. But the textbook's water is not enough water. The amount of water that has flowed through Knox Slot since the Pilbara stabilized is roughly known. The work that has been done is roughly known. The energy required to do that work against rock of that hardness is many orders of magnitude greater than the energy that the water carried. The Banyijima call the long, deep slots of Nox by a name that means the carts of the ancestor, not the river of the ancestor, not the valley of the ancestor. The carts, the word is specific. The word knows what it is talking about. Walk back up out of Nox in the late afternoon. The light comes down from above and lights the upper edges of the walls, and as you climb, the depths of the slot fall into shadow below you. By the time you reach the rim, the bottom of the cut is invisible, black, as if the cut had no floor at all, as if it just went down forever, into the body of the old world. Sleep if you can. The cut is patient. The cut has been waiting 2 billion years. It will wait one more night. Goodnight Knox, number 6, Hammersley Gorge. Hammersley is the strange one, the folded one, the one that gives the geologists their best and most uncomfortable talking point, because Hammersley shows you something the others hide. Hammersley shows you that the rock here, the 2.5 billion year old banded iron formation that everyone agrees should be flat and stable, is in fact bent, folded, twisted, curled up on itself like wet paper that was crumpled and then frozen. Walk to the pool at the bottom of Hamersley in the late morning. The water is green. The walls rise on either side. And then look at the walls. Look closely. The bands of iron which at Dales and Hancock and Weeno ran horizontal, here run in great wide curves. They sweep up. They sweep down. They form a shape that the geologists call a syncline, or sometimes more dramatically a chevron fold, where layers of rock that were once flat and horizontal have been bent into curves with sharp peaks and troughs, like the wave forms you see on a heart monitor. The textbook explanation is mountain building. At some point, the geologists say, perhaps 1 billion years ago, perhaps later, the Pilbara was caught up in a slow continental collision, and the layers were squeezed and folded by the immense pressure of plates moving against each other. The folds at Hammersley are the visible record of that squeezing. The rock bent rather than broke, because the pressures and temperatures involved made it slightly plastic, like cold caramel. Over geological time, almost anything can be bent if the pressure is applied slowly enough. That is the official story, and it is reasonable, and it may even be partly true. But here is what the story does not quite get to. The fold at Hamersley is exposed, visible, open to the air, sliced through. The gorge cut at Hamersley does not just go through the rock. It goes through the rock at exactly the angle that reveals the fold most clearly, as if whoever cut the gorge wanted to show the fold, wanted the cross-section to display the bent layers, wanted, if you will forgive the language, to put the geology on a museum stand. The chance of a random water channel finding exactly the right line through a folded rock mass to display the fold in cross-section is small. The chance that the channel would then sit there for hundreds of millions of years, displaying the fold to anyone who came by, is smaller still. And yet there it is, the fold, beautifully exposed, as if the gorge was cut here, in this exact line, to show what was inside the rock. The pool at the bottom of Hamersley is one of the loveliest pools in Karajini. The water is deep green. The walls curve around you in chevrons and arches and great soft S-shapes. If you swim out to the center of the pool and float on your back, the bands above you wheel slowly around the rim of your vision, and you have the distinct uncomfortable feeling that you are floating in a great library, surrounded on every side by the pages of a single open book, and the book is the body of the earth itself, The local Aboriginal name for Hamersley, in one of the language traditions of the region, translates as the place where the inside shows, the inside of the rock, the folded layers, the story of the deep earth laid open by something that came through here once and made a window. A window, that is the right word. Hamersley is a window, and someone or something cut the window. Lie still, breathe in, breathe out, let the green water hold you up. Let the curved walls move slowly around the edge of your closed eyes. Let yourself drift. The window has been open for a very long time. It is in no hurry. Good night, Hamersley. Number 7, Calamina Gorge. Calamina is the gentle one. After the dramatic walls of Knox and the folded chevrons of Hamersley, Calamina feels almost civilized. The walls are lower, only 50 or 60 meters. The floor is wider, the pools are calmer, the walking's easier. Calamina is the gorge you take an older relative to, the gorge you can wander through with a child by the hand. But do not let the gentleness fool you. Calamina, in its own quiet way, is one of the most peculiar cuts in the Pilbara. The walls of Calamina are made of the same banded iron, but they are interrupted again and again by horizontal layers of softer rock. The geologists call these layers shales. They are dark, almost black, finer grained than the surrounding iron, and they protrude from the walls in flat shelves where the harder iron has weathered back around them. Walking down Calamina is like walking down a hallway with shelves built into both sides, long flat shelves at regular intervals, going as far as the eye can see. The intervals are the suspicious part. The shelves repeat, the same band, the same thickness, the same protrusion from the wall, every few meters of vertical drop. You climb down a short ladder, you walk a few hundred meters along a shelf, you come to a small drop, you descend, and you're walking along another shelf. The same shelf in effect, the same horizontal layer of rock, exposed at a new level. The whole gorge is structured like a stepped library, levels stacked one above the other, each level a long, flat walking surface, each level connected to the next by a small drop or a short ladder. The geologists say this is the natural result of differential erosion. Some layers of rock are harder than others. The harder layers stand out as cliffs. The softer layers between them weather back to form ledges. Over millions of years, you get a stepped wall like the walls of Calamina. This is true. It happens. You can see this kind of stepping in many sedimentary canyons around the world. The Grand Canyon shows it on a vast scale. But in the Grand Canyon, the steps are huge, hundreds of meters between levels, and the layers themselves are varied and unevenly spaced. In Calamina, the steps are small, the layers are remarkably regular, and the spacing is so consistent that it begins to feel architectural rather than geological, as if someone had ruled the levels in advance and then cut to the rules. Walk along the floor of Calamina in the late afternoon. The light comes down from the sky in long slanted bars, falling across the shelves and lighting up the protruding edges in lines of fire. You can stand in one place and look down the gorge and see the shelves repeating, going away in perspective, smaller and smaller, until they vanish in the distance into the haze of red dust. It is one of the most peculiar perspectives in the country, a natural colonnade, a natural arcade, a natural library. There are on the walls of Calamina, in a few places, what appear to be marks, faint vertical scratches, sometimes in groups of 3 or 4, sometimes spaced regularly. The geologists call these stress fractures, jointing patterns, weathering features. Maybe They look, to an unprejudiced eye, like the kind of marks you find on a quarry wall, where someone has measured down the rock face and made small notches to indicate where the next cut should be. Maybe they are not. Maybe the eye sees what it wants, but the marks are there. You can photograph them. You can run your fingernail across them and feel the slight irregularity in the otherwise smooth stone. The Banijima word for Kalamina, in some sources, translates roughly as the place of many shelves. The descriptive name is unsurprising. The world's languages tend to name things after their most obvious features. But the choice of shelves rather than river or pool or even cliff says something about which feature of the gorge struck the old people most forcefully. Not the water, not the depth, the shelves, the regular shelves. As if even tens of thousands of years ago, the people who walked here recognized that the structure of this place was unusual, was repetitive, was in some quiet way made. Walk back up out of Kalamina at sunset. The light goes red. The shelves catch the red light. The whole gorge becomes a stack of long red lines, one above the other, going up the wall to where the sky shows blue overhead. It is the kind of view you would frame and hang on a wall if you could. It is also the kind of view that if you saw it on another planet through a telescope, you would call evidence of construction. The gorge has been here a very long time. The shelves have been here a very long time. The marks, whatever made them, have been here a very long time. We will not solve it tonight, but we will keep walking. Good night, Kalamina. Number 8, Murchison Gorge. We move now away from the Pilbara and south into a different country, into Kalbarri National Park, where the Murchison River, when it runs, makes its long, slow loops through a landscape of red sandstone and dry scrub and salt-tolerant grasses. Murchison Gorge is the largest and longest river gorge in Western Australia. 80 kilometers of cut sandstone, in places 300 meters deep, in places only 10 or 20 meters wide at the floor. The river itself, when you see it in person, is almost always a chain of pools. A trickle here, a still green stretch there, a few meters of running water in the wet season. The kind of river you could step across in most places if you were careful where you put your foot. This is the river that supposedly cut Murchison Gorge. Now, in fairness, the official story is more reasonable here than in the Pilbara. The rock is softer. The sandstone of Kalbarri is a marine deposit from about 400 million years ago, much younger than the banded iron of Karajini, and considerably easier to erode. The Murchison River, while small now, may have been larger in the past, during wetter epochs of the Australian climate. The textbook story, given those caveats, has more room to work. Over the course of perhaps 50 million years, a slightly larger river, in slightly wetter times, cut its way down through the soft sandstone, meandering as it went, leaving the long looping gorge we see today. That is the textbook story, and for the broader curves of the gorge, it is probably approximately right. But there is a place in Murchison Gorge called Nature's Window. You may have seen it on a postcard. It is a natural arch of red sandstone, perhaps 3 meters high, framing a view of one of the great looping bends of the river below. People walk to it, people stand in it, people take photographs through it. Nature's Window is one of the most photographed natural features in Western Australia. Look at Nature's Window carefully, not the view through it. The arch itself, the arch is rectangular, almost rectangular. 2 flat parallel sides, a flat top, a flat floor. The corners are not sharp 90-degree angles. They are slightly rounded by weathering. But the basic geometry is the geometry of a doorway, a frame, a window in the architectural sense, not just the metaphorical sense. The geologists say this is differential erosion of a horizontal layer of softer rock between two layers of harder rock. The softer layer weathered away. The harder layers stayed. You get a flat-topped, flat-bottomed opening in the rock. This is correct in the sense that the physics is plausible. It happens in many places. But the proportions of nature's window, the ratio of height to width, the precision of the flat surfaces, the way it frames the view of the gorge with such satisfying compositional balance, all of this is more than physics alone tends to deliver. Physics tends to deliver irregularity. Physics tends to deliver soft curves and broken edges and asymmetric openings. Nature's window is, by accident or otherwise, symmetric, rectangular, and proportioned, as if someone had cut it, as if someone had wanted a frame for the view and made one. Walk along the rim of Murchison Gorge from nature's window. The rim is flat, astonishingly flat. The rock at the top of the gorge has been planed off across enormous distances into a tabletop that runs for kilometers without significant relief. Geologists call these surfaces peneplains, and they explain them as the result of very long periods of erosion bringing the landscape down to a roughly horizontal level. This is fine, this works. But the flatness at Kalbarri is unusual even by the standards of peneplains. The top is too flat, too clean, as if the level had been set with a long straight edge and the rock above the line removed. If you fly over Murchison Gorge in a small plane, which you can do from the town of Kalbarri at the river mouth, you will see something even stranger. The gorge meanders, yes, in the loops that the textbook predicts for a river, but the loops are too regular. The radius of the bends is roughly similar. The spacing between bends is roughly similar. The whole gorge, seen from above, looks less like the chaotic wandering of a natural river and more like a planned curve, a sinusoidal route, a path that was laid down with care and then cut to that path. There is a section of the gorge called the Loop where the river makes a near complete circle, almost returning to itself before continuing downstream. The Loop is one of the most photographed bends in any river in Australia. Stand on the rim of the Loop and look down. The cliff drops 150 meters. The river curls below you like a thrown rope. The rock on the inside of the Loop is the same height as the rock on the outside of the Loop. There is no levee. There is no terrace. There is just a curl in the cut, perfectly horizontal at the rim, with the river snaking through the bottom of it as an afterthought. The Nunda people, whose country includes the Murchison, have stories of the great serpent who came up out of the sea and made the cut, not the river. The serpent. The river came after. The serpent was the cutter. The river is what arrived later to walk the channel that had already been made. Notice that pattern. We have seen it now in two distinct regions, hundreds of kilometers apart, in cultures with distinct languages and distinct traditions. Karijini, the Banijima, the rainbow serpent passing through the rock. Kalbarri, the Nanda, the great serpent making the cut. In both stories, the cut comes first. The water comes second. The water is the resident, not the architect. This is not how rivers work anywhere on Earth. Rivers make their own channels. Rivers fit themselves to the land. The idea that the channel could exist first and the river could move in later is foreign to the geological imagination. But it is not foreign to the imagination of the people who have lived in these landscapes for 40,000 years. To them, the cut came first. The cut was an event, the water was the afterthought. Sleep on that. Let it settle, we will not resolve it. We will only carry it with us as we walk on through the canyons. Goodnight Murchison, number 9. The Z-Bend. Just upstream from nature's window, the Murchison River makes a sharp double turn called the Z-Bend. The name is descriptive. The river, having flowed roughly southwest, takes a hard right, runs for perhaps 400 meters in a new direction, then takes a hard left and resumes its previous course. From above, the bend looks like the letter Z laid sideways. From the rim, looking down, the bend looks like the corner of a stone room. Rivers do not, as a rule, make sharp angles. Rivers curve, rivers loop, rivers meander. The forces that govern the path of a river are continuous forces, gravity and water pressure and bank cohesion, and continuous forces produce continuous curves. A river making a sharp right angle is the kind of thing that, when you see it on a map, you assume must be the work of a person, a canal, a drainage ditch, an old mill race, not a natural channel. The Z-Bend is a natural channel, or so we are told. The geologists explain the sharp angles as the result of the river following pre-existing fractures in the rock. The Murchison sandstone, they say, has joint patterns that run in 2 perpendicular directions. The river found the joints, exploited them, and the angles of the joints became the angles of the river. The river is straight where the joints are straight. The river turns 90 degrees where the joints turn 90 degrees. This is a respectable explanation. It is also incomplete. Joint patterns in sandstone are not usually perfectly perpendicular. They are subperpendicular, near perpendicular, with statistical variation around the average. A river following such joints would show angles of 70 degrees, 80 degrees, 110 degrees, all the kinds of variation that geometry permits. The Z-bend, when you measure it carefully, is close to 90 degrees both times. The 2 sides of the Z are parallel. The connecting section between them is at right angles to both. This is not just joint following. This is geometric precision that goes beyond what joint following normally produces. Stand at the rim of the Z-bend at sunset. The light comes in low from the west. The shadows of the cliffs fall across the river in long, sharp triangles. The geometry of the bend is even more visible at this hour because the shadows pick out the angles. You can see from the rim that you are looking down into what looks for all the world like a corner of a room cut into stone, a great roofless room 300 meters deep, with the river running along the floor of it. The Aboriginal stories of the Nanda speak of 2 ancestors who met at this place. They came from different directions. They turned, they met. Where they met, the cut changed direction. The angles of the Z in this telling are the angles of the meeting, the angles of negotiation, the angles where 2 paths intersected. Hear that as you will. Take it as poetry, take it as cosmology, take it as a story that comes very close in its specifics to describing something that is otherwise hard to describe. 2 cuts that meet at an angle and create a Z. That is the Z-bend the story knows. Lie back. The river runs through the corner of the room, slowly, almost not at all in the dry months. The walls hold the cool of the night, even into the heat of the morning. The Z-bend has been there a long time. The Z-bend will be there for a long time more. Sleep if your eyes are heavy. The bend can wait. Good night, Z-bend, number 10, Yardie Creek Gorge. We move now to the western edge of the continent, to Cape Range, where the long, thin peninsula of Cape Range National Park reaches north into the Indian Ocean and forms the protective arm behind the Ningaloo Reef. This is a different country again. Limestone, not banded iron, not sandstone. White and pale grey and beige instead of red. Coral cliffs above turquoise water. The geology is younger here. The rock is softer. The expected story should be more easily believed. Yardie Creek Gorge is the largest of the gorges in Cape Range. The creek itself runs only in the wet season, but the gorge holds a permanent saltwater inlet from the ocean, so that walking along the rim of the gorge, you are looking down at green still water with the occasional sea turtle drifting through, and saltwater crocodiles, on rare occasions, sunning themselves on the rocks at the edge. The contrast between the red and brown gorge walls and the green saltwater below is one of the more startling color palettes in the country. Look at the walls. The geologists are correct. This is limestone. Soft marine limestone full of fossils, shells, coral fragments, the calcareous record of an ancient warm sea. Limestone erodes in characteristic ways. It dissolves under acidic water, it forms caves, it develops the rounded, pitted, fluted surfaces that geologists call karst. You see karst features everywhere in Cape Range: sinkholes, cave entrances, pitted rock surfaces. The textbook story works here, but the gorge itself, the long straight cut that holds the saltwater inlet, does not look like karst. Karst makes irregular shapes, rounded chambers connected by twisting passages, sinkholes with funnel sides, caves that follow the bedding planes and the joints in the rock in unpredictable ways. Karst is not straight. Karst is not parallel-walled. Karst is not flat-floored. Yardie Creek Gorge is all of these things: straight, parallel-walled, flat-floored, with clean vertical walls that drop 40 or 50 meters to the green water below. The textbook explains this as the result of the gorge being cut by a much larger creek during a wetter past climate. The creek deepened along a fault line in the rock, the geologists say, and the gorge took its current shape during the last glacial period when sea levels were lower, and the creek was running with more force. This is plausible. It may even be partly true, but it does not entirely explain the geometry. A creek cutting along a fault line typically widens at the top and narrows at the bottom, because the upper layers are exposed longer to weathering. Yardie Creek Gorge is the opposite. The bottom is wide, the top is narrow. The walls are vertical or even slightly overhanging in places. The cross-section, drawn on a piece of paper, looks like an upside-down trapezoid, a shape that water erosion does not normally produce. Walk along the rim trail. The wind comes off the ocean in long, warm gusts. The grasses on the rim move in waves. The color of the rock is the color of dried bone. Look down into the gorge. The salt water is so still you can see the fish below the surface, drifting along the underwater shelves of the walls. The shelves are themselves a peculiar feature. They run horizontal, both above and below the waterline, at very regular intervals, as if the gorge had been cut in stages, as if the cutting tool, whatever it was, had been lowered through the rock in measured steps, leaving a small ledge at each step. The local Aboriginal name for Yardie Creek translates in some renderings as the cut to the sea, not the river to the sea, the cut to the sea, the naming convention again. The cut is the noun, the water is the descriptor. Beyond the end of the gorge, where the saltwater opens into the lagoon and the lagoon opens through the reef into the open ocean, the cut continues. You cannot see it from the surface, but bathymetric surveys show that the channel extends offshore for several kilometers in a roughly straight line as a submerged feature on the seabed. A channel that was once above water when sea level was lower, and that has continued in the same direction even where the rock is different. The whole length of the cut from inland gorge to offshore submarine canyon is something like 15 kilometers. 15 kilometers of cut in roughly one direction, regardless of what kind of rock it was cutting through. Sleep with the saltwater inlet still in your mind. The cut goes from the dry country to the sea. The cut crosses everything in its path. Whatever made it was not bothered by what kind of rock was in the way. It just continued. Good night, Yardie Creek. Number 11, Mandu Mandu Gorge. A few kilometers south of Yardie Creek, in the same long limestone spine of Cape Range, is a gorge called Mandu Mandu. It is shorter than Yardie. It is drier. There is no permanent saltwater inlet at the bottom of it. Mandu Mandu is, on the surface, a small gorge, and most visitors to the area drive past the turnoff without stopping. But Mandu Mandu hides one of the more uncomfortable little facts about Western Australian gorges. Mandu Mandu, when archaeologists excavated it in the late 20th century, gave up shell beads. Shell beads. Pierced and threaded shell beads, used as ornament, perhaps as necklaces, perhaps as ceremonial decoration. The age of those shell beads, established by radiocarbon dating, came out to roughly 32,000 years. 32,000 years, older than the cave paintings of Lascaux, older than the figurines of Hohlefels, older than almost any worked ornament that has been dated anywhere in the world. The shell beads of Mandu Mandu sit in the company of the earliest known human ornaments on the planet. What does this have to do with the gorge being cut by something other than water? Holds the question. We will get to it. Walk into Mandu Mandu in the early morning. The walls rise on either side, white and beige and the faintest pink where iron has stained the limestone. The floor is dry, mostly stones and gravel, with a few pools of standing water in the rare wet season. The walls are not as dramatic as those at Yardie Creek, lower, 20 or 30 meters in most places, but the walls are still vertical, still parallel, still flat-floored. The same trapezoidal cross-section as Yardie, wider at the bottom than at the top. The walls of Mandu Mandu are pocked with caves, small caves mostly, the kind of openings in the rock that limestone naturally produces. Some of them are barely more than overhangs. Others go back into the cliff for 10 or 15 meters before they pinch out. These caves were where people lived 30,000 years ago, maybe more. The ash from their fires, layer on layer, lies on the floors of those caves, with stone tools and shell beads, and the bones of fish and turtles and emus mixed into the dark sediment. Here is the uncomfortable fact. The caves are not random. The caves are spaced along the walls at intervals that are, if not perfectly regular, then suspiciously regular. They are at roughly the same height above the floor. They face roughly the same direction. They are roughly the same size. If you walked along the gorge and counted them, you would find a kind of cadence. Cave, stretch of wall, cave, stretch of wall, cave, as if they were not natural cavities at all, but something more deliberate, something carved, something cut into the walls for a purpose. The textbook explanation is that the caves are formed at the level of an old water table. Groundwater at a particular level in the past dissolved the limestone preferentially at that horizon. Caves formed along that line of dissolution. The caves are at roughly the same height because the water table was at one height. The caves face the gorge because the gorge cut through that horizon and exposed the cavities. This is plausible. This is the standard model. And it explains a lot of what we see, but it does not explain the spacing. Water table cave formation is irregular. Sometimes caves cluster, sometimes they are far apart. Sometimes they merge into long horizontal passages. The Mandu Mandu caves do none of these things. They are individual, spaced, cadenced, as if someone had decided how far apart they should be and then made them at those intervals. Now bring the shell beads back into the picture. 30,000 years ago, when those beads were made and worn, someone was living in those caves. They liked them, they came back to them, they were comfortable there. The caves were good for habitation. Now, could the people who lived in them have made them, modified them, enlarged what was already there to fit themselves more comfortably? Yes, almost certainly. The walls of some of these caves show, when you look closely, what appear to be cutting marks, tool marks, the sort of regular shallow indentations that you get when someone with a hard stone tool chips away at a softer stone surface to enlarge a hollow. Or, and this is the harder version of the thought, the caves were already there when the people arrived in regular spacing at regular height, on the walls of a regularly cut gorge, already made, by whoever cut the gorge. 30,000 years ago, the people who came to live in them recognized that they were dwelling in something prepared, something pre-made, something that the cutters had left behind, perhaps for them, perhaps simply as a side effect of the larger work. The Aboriginal stories of the area, the Yinikutira and Bayungu peoples, speak of the spirit beings who shaped the country before people arrived. The country was prepared, the caves were prepared, the springs were prepared, the places of food and water and shelter were prepared. When the people came, they found a country that had been made ready for them. The stories do not always specify who or what did the preparing. The stories just say it was done. Lie down, imagine the gorge of Mandu Mandu in the dawn, the caves along the walls, dark mouths evenly spaced, the grey limestone catching the first light, somewhere up the gorge. A small fire smokes in one of the caves, and someone 30,000 years ago wakes from sleep, steps out into the cool morning, and looks at the walls of their gorge the way you might look at the walls of your bedroom. Walls that were already there, walls that did not have to be explained. Good night, Mandu Mandu. Number 12, Charles Knife Canyon. A little further south along the Cape Range Peninsula, perhaps 30 kilometers as the crow flies, is one of the most photographed and least explained landforms in Western Australia. Charles Knife Canyon. The name comes from a surveyor named Charles Knife, who in the early 20th century was the first European to put the canyon on a map. But the canyon itself, which the local Yinikutira people knew by other names long before any surveyor arrived, is older than any name. Charles Knife Canyon is shaped, when you look at it on a topographic map, like the blade of an enormous serrated knife. The main canyon runs roughly east to west for about 15 kilometers. Along both sides of the main canyon, like teeth on the blade of a saw, are subsidiary canyons, side canyons, each one cut perpendicular to the main canyon into the surrounding plateau, in regular spacing along the entire length of the main cut, 18 of them by one count, 20 by another, cut into the plateau like the regular teeth of a comb. Stand at one of the lookouts on the road that runs along the rim of Charles Knife. The road itself, built by the Park Service, follows the spine of one of the long fingers of plateau that separates the side canyons. Looking left and right from the road, you see down into the parallel side canyons on either side. Looking ahead, you see the road sloping gently down the spine. The side canyons all run the same direction. The side canyons all have roughly the same depth. The side canyons all have roughly the same length. From above, the shape of the whole landform is so regular that if you saw it on satellite imagery of another planet, you would describe it as artificial. The geological explanation is that Charles Knife is a dissected anticline. The whole peninsula was uplifted into a long ridge or arch, and the center of the arch was eroded out by the main canyon, while the flanks of the arch were dissected into ridges and side valleys by the perpendicular erosion of tributary streams. The streams ran from the high spine of the arch downhill to the lowlands on either side, and over time they cut the regular pattern of ridges and valleys we see today. This is the textbook story. But the streams in question do not exist, or rather, they exist in only the most ghostly form. The side canyons of Charles Knife are dry, not just dry today, dry for as long as anyone has been keeping records. There is no evidence of significant flowing water in any of them in the recent past. There are no riverbeds, there are no scour marks, there are no depositional fans where the side canyons join the main canyon. The side canyons just exist, identical, parallel, dry, going nowhere. They are not the visible remains of an active stream pattern. They are the visible remains of something that was once cut and has been sitting there, slowly weathering ever since. Walk along the rim of one of the side canyons. The cliff drops perhaps 80 meters. The far wall of the side canyon, perhaps 200 meters away, is parallel to the wall you're standing on. The floor of the side canyon between the two walls is dry and stony and slopes very gently downhill. You can see, if you look carefully at the floor, the lines where stratified rock layers are exposed. The layers tilt slightly. The geologists say this is the result of the uplift of the anticline. The flanks of the arch tilt away from the spine. The layers in the rock follow the tilt. But here is the strange thing. The walls of the side canyon do not tilt. The floor tilts mildly. The walls are vertical, as if the walls were cut after the rock was tilted. As if someone said, here is a stratified rock formation that has been tilted by uplift, and now we will cut perpendicular trenches through it, regardless of the angle of the bedding, because the trenches will be vertical, and the bedding can be whatever angle it wants. That is, of course, an absurd description of water erosion. Water erosion follows the rock. Water finds soft layers and exploits them. Water does not cut at right angles to the bedding when the bedding is sloping. Water does what is easy. The cuts at Charles Knife are not what is easy. They are what would happen if a careful saw was drawn along a planned line, regardless of the rock structure underneath. They are what would happen if someone said, I want these trenches here in this direction, at this spacing, at this depth, and brought a tool to bear that did not care what the rock was made of. The color of the rock at Charles Knife is one of the most distinctive in Western Australia. In the early morning, the walls are pale rose. In the middle of the day, they bleach to a creamy white. In the late afternoon, they go red, then deep red, then the color of an old brick. At sunset, the side canyons fill with shadow, while the spines of the ridges between them stay lit. The whole landform becomes a comb of light, with the teeth of the comb glowing against the dark sky and the gaps between them already night. It is one of the strangest landscapes in the country. It is also one of the most overlooked. People drive past Charles Knife on the way to the beach. People do not pull off and read the rock. The rock would tell them something if they did. The Yinikutira people, whose country this is, have a tradition that translates roughly as the place where the blade was drawn. Note the word. Blade drawn. As if someone took a blade and drew it through the country. As if the long main canyon and its perpendicular teeth were the marks of a single tool, used in a single sustained pass. Sleep. Let the comb of light fade in your mind. Let the dry, parallel canyon settle into the dark. Good night, Charles Knife, number 13. Shot Hole Canyon, just south of Charles Knife, parallel to it, separated by only a few kilometers of low ridge, is a second canyon called Shot Hole. The name comes from the early oil exploration in the area. Surveyors drilled shot holes in the rock to set off small explosive charges and measure the resulting seismic signals looking for hydrocarbons. The shot holes gave the canyon its English name. The Yinikutira name, which is older, refers to the canyon as a sibling to Charles Knife. The two of them parallel side by side, like two cuts made by the same hand. Drive down the road that runs along the floor of Shot Hole Canyon. The road is rough. 4-wheel drive recommended. The walls rise on either side, perhaps 150 meters at their highest, with the same comb-toothed side canyons running off perpendicular to the main canyon, the same regular spacing, the same parallel walls, the same flat-floored trapezoidal cross-section. If Charles Knife and Shot Hole were the only two canyons in the area, you might shrug and say, well, two parallel canyons cut by the same drainage system, no big deal. But there are more. There are 6. 6 roughly parallel canyons cutting across the spine of the Cape Range Peninsula, with regularly spaced side canyons branching off each one. 6 parallel, spaced approximately evenly, as if someone, having made one cut, lifted the tool, moved it sideways a fixed distance, and made another cut, and then again and again, 6 times. The geological explanation, again, is that this is the dissection of a regional anticline by parallel drainage systems. The same uplift that produced Charles Knife, produced Short Hole, produced the others. The drainage developed in parallel because the topography was symmetrical. This is consistent. This is reasonable. This is the kind of pattern that erosion can sometimes produce on a regional scale. But the regularity is too clean. The spacing is too uniform. The depth of cut is too similar. The side canyon spacing within each main canyon is too consistent across all 6. Real erosion patterns, when you map them out across a region, show all kinds of irregularity. Some valleys are deeper, some are wider, some have more side canyons than others, some develop dense dendritic networks of tributaries, some are simple slots with no branches at all. The Cape Range canyons are all alike, all 6, as if they were produced by a single process, applied uniformly, in a single time window. The official timeline for the development of these canyons is somewhere in the range of 2 to 10 million years, depending on which geologist you ask. The dates are vague because the dating is difficult. The rock is the same age everywhere. The erosion features cannot be radiometrically dated directly. You have to rely on indirect indicators, sea level history, regional tectonics, comparisons to other better dated landscapes. The dates are best guesses. They could be older, they could be younger. What if the dates are wrong and the canyons were cut much faster? much more recently by some process that operated quickly. What would that process look like? It would look like something that could cut limestone in straight parallel lines, that could maintain consistent depth, that could repeat its operation at regular intervals across a region. There is no natural process known to modern geology that does this. The closest analogues are not natural. The closest analogues are quarries, where humans cut parallel trenches at regular intervals to extract building stone. Quarries on a vast scale with cuts 100 meters deep and 10 kilometers long are unknown anywhere in the world. We do not have the technology. Whoever did this, if anyone did this, had technology we do not have. This is not a comfortable thought. This is not the kind of thought that respectable people are supposed to entertain. But the rock does not care about respectability. The rock just sits there, parallel cuts, regular spacing, 6 in a row, in the limestone of the Cape Range Peninsula, and it sits there in defiance of all the standard explanations. The Yini-Kutura call this whole stretch of country a name that means the place of many blades. Many blades, drawn through the rock in rows in an order by something that had a plan. Pause, breathe. Let the comb of cuts settle in the dark behind your eyes. The cuts are still there. The cuts have been there a long time. They will be there longer than us. Good night, shot hole. Good night, sibling. Sleep deep. Number 14, Winjana Gorge. We move now into the Kimberley, the far north, where the country becomes even older, even stranger, even more difficult to fit into the tidy boxes of the textbook. Winjana Gorge is the first of 3 sister gorges we will visit in this region. All of them cut through the same enormous formation, all of them telling, in slightly different voices, the same uncomfortable story. The formation is the Napier Range. From a distance, the Napier Range looks like a long, low wall of grey limestone stretching across the plain. 30 kilometers long, in places only a kilometer wide, rising perhaps 100 meters above the surrounding flat country. It looks from the highway like the wall of a great old fortress, whose other parts have been weathered away. Like the foundation of a city that is no longer there. The local Bunuba people have stories about this. The wall, in their tradition, was once part of something larger, something that surrounded the country, something that was in some ancient time broken or removed, leaving only this long ridge as a witness. The geologists have a different story, but in some respects it is just as strange. The Napier Range, they say, is a fossil coral reef. 370 million years ago, in the Devonian period, this was the shore of a warm tropical sea. Corals grew along that shore in vast complexes. The corals built reefs. The reefs accumulated limestone over millions of years. Then the sea retreated, the climate changed, the reefs were left high and dry, and they have been weathering ever since. The Napier Range is what remains of that reef. It is, by some measures, the oldest continuous reef structure on Earth. A fossil reef from when the seas were warm, a long wall of limestone hundreds of millions of years old, running across the country. Both stories agree on something fundamental. The thing was once continuous, and now it is partly removed. The gorges, then. Winjana Gorge is cut through this ancient reef. The Leonard River, in the wet season, runs through Winjana with great force. In the dry season, the river retreats to a series of long, deep pools, full of freshwater crocodiles, sometimes 100 of them in a single stretch, lying along the banks like logs. The gorge walls rise on either side. Grey limestone, full of fossils, The shells of brachiopods, the segments of crinoids, the corals themselves, all of them visible if you look closely at the rock. The walls are sheer. The geologists say this is because the limestone is hard, full of compact coral, and resistant to weathering. This is true. The rock is hard, but the cut through it is, again, suspiciously clean. The walls rise 80 or 90 meters from the river to the rim. They are vertical. They are roughly parallel. The floor of the gorge is wide enough to drive a vehicle along in some places, narrow enough to throw a stone across in others. The cut is, in cross-section, like the cut of an axe through the wall of a fortress. A single sustained blow that went straight through. There is a section of Winjana where the walls show, in cross-section, the entire structure of the ancient reef. Coral growth bands, layers of reef front talus, patches of back reef lagoon sediment. It is, like Hammersley Gorge in the Pilbara, a beautiful cross-section of internal structure, as if the cut here was made specifically to display what was inside the reef, as if someone wanted to see the structure of the thing they had cut. The geologists love this exposure. They have written entire careers based on the rocks visible in Winjana. The exposure is so clean, so revealing, so beautifully laid out for inspection, that it is the textbook example of an ancient reef. Anywhere you go in the world, if you study Devonian reefs, you will encounter the Winjana exposure in your reading. A cut that beautifully reveals an internal structure, a cut through hundreds of millions of years of accumulated reef growth, made by a small river that flows only seasonally, or made by something else that wanted to see what was inside. Walk into Winjana in the late afternoon. The light comes in from the west between the cliffs and lights the eastern wall in long bands. The river pools are dark green, almost black where the water is deep. The crocodiles lie on the banks unmoving, watching with their slow yellow eyes. The walls rise around you. The grey limestone is patterned with fossils so dense that in places the rock is more fossil than matrix. Whole ancient organisms preserved in their living positions, cut through and exposed. The Bunuba people call this place by a name connected to the Winjana, the rainbow serpent, who in their tradition came through this country during the deep time and made the gorges. The serpent went through the reef broke open, the serpent kept going. Where the serpent had been, the gorges were left behind. The Winjana Gorge takes its English name from this story. The Aboriginal name is older and more specific. The cut in their language was the serpent's path, a path through a wall, a path that cut clean, a path that did not wander, lie back. Let the cool air of the gorge settle on your face. The crocodiles do not move. The water does not move. The reef has been there for 370 million years. The cut has been there, who knows, long enough that the people who came here recognized it as old, as already old, as having been made before the time when story began. Good night, Winjana. Number 15, Geiki Gorge. A few hours' drive east of Winjana, along the same long line of the ancient reef, is the gorge called Geiki. The local Bunuba name is Danku, and that is the name you should use if you go there, because the people whose country it is have asked for it. Geiki was an English geologist who never visited the place but who studied the rocks from a distance. Danku is what the people who walk the gorge call it. Danku it is. Danku is, in some ways, even more striking than Winjana. The walls are higher in places, almost 120 meters. The water is deeper, holding water year-round, fed by the Fitzroy River. The gorge runs for several kilometers, with the same parallel walls of ancient reef limestone on either side. Boats run on the river in the dry season, taking visitors along the gorge between the cliffs, and the boats are often the only way to see the walls properly. You can drift along the green water, looking up, and the cliffs rise on either side in vast sheer surfaces that are colored in great horizontal bands. The bands are the strange thing. The walls of Danku are colored in stripes, white at the bottom near the present water level, then a band of warm orange, then a band of black gray, then white again, then orange, then dark gray. The bands are roughly horizontal. They run for the full length of the gorge. They are the result, the geologists say, of the variable wetting of the limestone by the river over different historical water levels. Where the river has stood at a particular level for a long time, the rock has been stained one color by the algae and lichen and chemical reaction with the water. Where the river has been higher or lower at other times, other colors have been deposited. The bands record, in their color, the history of the river over thousands of years. This is plausible. This is the textbook story. It is probably partly right, but the bands are very crisp. The boundaries between them are sharp, not gradual. A clear line where the orange ends and the gray begins. A clear line where the gray ends and the white begins. The lines are level, horizontal, accurate to the centimeter across the entire length of the gorge. Algae stains do not normally make lines this sharp. Chemical weathering does not normally produce boundaries this clean. There is something about the cut, or about the rock, or about the process that colored the walls, that has worked with the precision of a horizon line drawn on a sheet of paper with a long straight edge. You see this kind of banding in some swimming pools, the waterline mark, the narrow horizontal stripe where the water level has stood. In a swimming pool, the boundary is sharp because the water level is constant, the boundary is mechanical, the line is the line of the water surface. To get equivalent sharpness on the walls of a natural gorge, you would need water levels that were also constant for long periods, with the transitions between levels happening quickly. This is possible. It is what the geologists assume. But it is also worth noting that the sharpness of the bands at Danku is the sharpness of an engineered surface. The sharpness of something measured. The sharpness of something that knew where it was supposed to stop. Float in a boat along Danku in the late afternoon. The walls rise on either side. The bands of color run along them, white, orange, gray, white again. The water is the color of weak tea, almost flat calm, with the occasional rise of a fish, the occasional drift of a freshwater crocodile in the shallows. The walls reflect in the water, doubled so that the bands appear above and below, mirrored across the line of the water surface. You are floating in a long room of striped stone, with the stripes running on every wall in perfect horizontal lines, at perfect identical spacing, for as far down the gorge as you can see. It is one of the most peculiar interior spaces in the country. It feels more than any other gorge like a room, like a corridor, like a chamber that has been prepared. The Bunuba stories of Danku speak of the serpent again, the same Winjana spirit who came through and made the cut. They also speak of the bands. The bands in some tellings are the marks of the serpent's body where it pressed against the walls as it passed. The marks of contact, the lines where something tremendous slid through and left its trace. Translate that as you will. Take it as story, or take it as a description in the language of 40,000 years ago of an event that left horizontal bands at regular spacing on the walls of a perfect